Hello, welcome to episode 163 in this series where I am programming an NES game live on Twitch from scratch. Let's get back into the code. So, actually, I take that back. One thing we should look at before we go back into the code, I meant to bring this up and forgot up until I just said this. There is a really good video that Casey Muratori just posted. If you haven't watched it, it is called "Where Does Bad Code Come From?" I thought this was really good. It highlighted for me several things that I had thought about in my career as a programmer, and things that I always thought were kind of weird about the way modern software development is done. Some of those things have been corrected, some of them have not. He addresses a lot of stuff about how modern software is developed and why it's as problematic as it is. And even if you disagree with his take, it's worth watching to get a different perspective in how software development works, because the 15-second version of it is, even when you're experienced, you don't know what you're building unless you've built it already because you wrote the code. And so trying to design and plan in a design document that spells out things in a very, very specific way is basically a recipe for failure. So he goes into it a lot more than that, and explains what that means and why you end up with bad code that way. And I can say that from experience, he's 100% right about how it's really easy for people to put together designs that sound good on paper and, even adhere to different principles of modern design and everything, but, they don't actually understand the problem that they're solving, 100%. And so you end up coding yourself into some bad situations. And then on top of it, in most of these scenarios where that happens, you don't have the luxury to go back. And I say luxury, but that's like in the strongest possible quotes, because it shouldn't be, but like you don't generally have the opportunity to go back and do it again. So unless it's like really terrible, I'll share an example real quick, a personal example, and then we'll get into the game code here. So at work, in a previous job, in my first job, I was working on building a service that went out and requested data from different machines on the network. The idea was that it would be monitoring those machines to see how much CPU, how much memory, how much disk space, all that stuff they were using, and do some calculations based on that, and then potentially act and react based on those values. And the first version of the implementation of that was pretty bad. And so it was serviceable up to maybe about 100 systems, maybe. But like once you got beyond that, it really didn't work very well. And in the looking back on it in hindsight, it's easy to say, well, why wasn't the scope more clearly defined? But it just wasn't at the time. Whether that was my fault for not asking, or the product manager or product owner's fault for not specifying, doesn't really matter. It just the point is it wasn't clear. And so what happened was we had a service that didn't scale to the size that we needed, which was thousands of machines. And as a result, what would happen is we'd get into a situation where we were trying to read from so many machines that it would get so far behind that you'd be piling up requests over time. And so then, because we had the opportunity to do it in a short time span, unfortunately, so it meant a lot of extra time and a lot of nights and weekends of me working on it, had the opportunity to rebuild that service from scratch to try and do a better job with it. And so we came up with this design, and I put together the design, and we reviewed the design. It was in this document, and as we're going forward, it's clear that the design is better than the original implementation, but still not quite what we needed it to be. And in the case of what is being said here in this video, again, watch it if you're interested in this at all. What should have been done is we should have, specified what the scope was, put together an experiment to see what implementations worked well for the type of scale that we were talking about, and actually try some things out before we settled on a design, and then went back and identified why we didn't go with the designs that were proposed, and ultimately went with the design that we went with. But because of how little time we had, and because of the problems that were in the original design, and how important it was to get the thing fixed and rebuilt, we couldn't go back and start over again. And that's really like the other thing is people always talk about, oh, well, we can rebuild it from scratch, right? Like it's not working, but it's okay. We know what the problem is. We'll rebuild it now that we know what the problem is. But I think that never actually happens in the way, like in that ideal way, or very rarely does it happen that you can rebuild it from the ground up in the amount of time you actually need, even if it's a shorter amount of time of the original thing. And then over time, you also forget about all the nuances and complexities of the original implementation of what you built. And those are the things that took you the most amount of time to implement and fix, not the core basic stuff that's like very straightforward. And so I think it's definitely better to choose, a few different approaches and experiment and kind of determine based on actual measurable outcomes what the implementation should be before moving forward with the full implementation, versus writing out a document that outlines like, oh, it's going to be these microservices with this cache and this distributed network layer and all this other stuff, when you don't really understand the problem. Fail fast, learn fast. That's a good way to describe it. And so it's like, and it doesn't even have to be a fail, right? Like it just might be that you implement one way and it takes 5 seconds to do something, and then you implement another way and it takes 2 seconds to do something, and both of them work, and 5 seconds isn't too bad, and 2 seconds is obviously better. There might be trade-offs that determine that you maybe want the 5-second version, but like that's the part that you need to actually move forward with and have the time to evaluate, because if you do that up front, you're going to end up with a better implementation, and you don't have to worry about going back and rebuilding something from scratch. And then later, another developer on the team had a more clear understanding of what the implementation needed to be, had a better understanding of some of the technologies that were being used for retrieving that data, and was able to rebuild the service to be able to request the data from thousands of machines without any slowdown or issues. using essentially asynchronous communications. It wasn't exactly asynchronous, but something to that effect for the sake of simplicity. And that's the thing. It's like we knew it could be done, but because we were so hung up on implementations and design docs and schedules, and delivering on those schedules, we didn't really have the time to come up with several different approaches that we could actually test empirically and ensure that we chose the best one based on the actual code and not just based on what somebody wrote in a Word document. So yeah, watch the video. It's a good video. It's on his Molly Rocket channel. It's not on Handmade Hero. But it's I don't know, something about it struck me pretty strongly. So I definitely recommend it if you have some time and you're interested in listening to that kind of stuff. And again, even if you disagree and you think software needs to be codified and written in large verbose design documents, it's worth hearing somebody's opinion that is different than yours so that you can understand why they disagree with your point of view. And then kind of it gives you the ability to have a good way of forming counterpoints to somebody else that you might encounter that has the same opinion as Casey, and many others. So anyway, that was a very long preamble, but anyway, I mean, some of that is applicable to what we're doing here. Obviously, with things like how we've reworked pieces of the game and the engine and the export, with the help of many folks. So one of the things that I wanted to do was we have the repeat scrolling working, and functionally it's great because it gives us exactly what we want in terms of a very simple way to store data that allows the maps to be very large, but not take up a lot of space on the ROM. We talked a lot about on Saturday, how much space we actually have available and what that actually looks like, and using different tools to evaluate that. But the biggest issue with this right now is that it's extremely repetitive, and so I wanted to implement something that would randomly provide us with a visual effect, kind of similar to what we have here, where we're only sometimes using the full metatile and other times we're using the empty tile. But in the end, the implementation that I was able to get done using the random number generator, or the pseudo random number generator really, was that the rows could be random. So you'd have a row of the little wavelet tiles. And we ran into, and I was discussing how there was some, basically some concern on my part about being able to store the data. But then Miralupa mentioned that, we could just use 2 bytes to represent whether or not we were using the blank or the little wavelet metatile, because that gives us 16 bits that we can use for storage. And if you look across here, it's 16 tiles, even though it's 32 8x8s. Our metatiles are 16 by 16, so we can use 2 bytes to represent one of these rows. So there were a couple of things that I wanted to do. I wanted to first start by just implementing something that will randomly generate a row by taking 2 numbers and filling in, and then using that as our row data to fill in the metatile on the name table. But more likely what'll end up happening is that random number generator will actually be used to select a set of these strips, and it's because of basically the fact that it being like actually random probably means we're going to get a lot of repetition in some strips that we put on the screen. But I want to actually see what that looks like. Maybe it's fine, maybe it's not. It's really easy to switch it so that we are going to, instead of using the 2 random numbers for our bytes, we will load those 2 bytes with values that are coming from just essentially a lookup table of these strips. And then we can have some more, what's the right word? Some more curated map strips to use in the game. So let's start with the basic implementation of this, and then we will go from there to something potentially a little bit more artistic rather than just purely random. So last episode we added the seed here for the random number generator. We'll call this loop strip, and this is our 2 bytes for our random strip of whether we're going to have a blank background or the little wavelet one. So let's see. The way that this needs to work at this point is we need to, when we get to process new row, we need to update, or is it process new row? Whatever it is, it's load new tile row. We need to come up with when we're gonna determine when we need to fill up those 2 bytes. Move this over here. The 2 bytes in loop strip, and then we're going to use that to determine if we're using this to look up or the other value. Now this is normally 0, but we can use the individual bits that are part of the strip to determine which one we're looking up for the purposes of the rendering we're doing. And in this case, I just want to look at how this whole flow works. So we have new tiles. Right. So this is our loop that's taking the information that we kind of dealt with here for the background metatiles. Hey, how's it going? Oh, I didn't switch to the view that you can actually see the chat. Sorry about that. And then here is where we're actually looping. Hey, Microman, how's it going? And so then we're gonna load that into new tiles. So let's see. I guess the first thing we need to figure out is BG tile is what's telling us which part of the actual meta tile we're looking into, and then we're just using that over and over and over again. So that part needs to change. That part needs to change in terms of the base index that we're using. So right now we're using temp as our base index. And we're going to have to recalculate that every time now. Before we had been... Before we had only done it once at the beginning of this section because it never changed, but now that we have load strip, or loop strip, I should say, it is possible that it's different every time. And then realistically, BG loop metatile is no longer kind of a constant. Hey, Miralupa. It is going to be kind of where we store. Well, maybe we'll use temp, because we were storing temp so that we had that for doing our base index here, but now we don't need to do that because we're going to be recalculating it. So all of this is kind of what did I remove here? So this is loading BG tile and then doing the exclusive OR and then storing it. Right, and that's because the last time through the loop we wouldn't have done that. So, okay, so that still needs to happen. This can go away. Or not go away, we're gonna kind of move that code over here. So now, maybe what we'll use BG loop metatile for we'll use BG loop metatile, we'll copy loop strip into it, and then we'll shift our bits out of BG loop metatile so we can use that for the purposes of determining which index we're using. Sorry, I bumped the mic there. So let's do this. Let's load a loop strip, and then we're going to store it into BG loop metatile. And then in this loop, we're going to load that, and then we're going to do an AND of 1 because we only want whatever the least significant bit of the byte. That's what we want. And then we're going to use that to look up in our lookup. And do we still want to store that in temp? I don't think we need to do that because the only thing I think we want to do 2 stores into new tiles. This way we don't have to store into temp. Because basically we're gonna load this value in, we're gonna AND it so we get the least significant bit. We're gonna do our lookup to figure out which metatile we want. We're gonna do our shifts to offset the index accordingly. And then we're adding BG tile to determine how which tile within the metatile we want to load, and then we're gonna actually look up that value and store it in new tiles X. But we want to do the process one more time. Let's see, I want to do it one more time without having to re-look up the lookup, essentially. So if we do it twice, then we're saving ourselves this calculation. Do I really care about that? I guess I do, because this is in the main game loop. Alright, so let's get rid of this. So we're going to add BG tile to that to figure out what actual tile we want. And we're going to do transfer of A to Y. Oh, but the only thing... because we're adding BG tile, if we... So I was just thinking, if we add BG tile, then we want to add... Do we want to go to the following one? All right, let's just do it one at a time. Let's not overly complicate this. Am I writing in Visual Studio Code? It compiles in C65. How does that work? Because I'm just using a makefile. So I'm just telling it to run this makefile to build. There are some other ways to do it, but and it's not perfect because the other thing is that there's potentially, like, I should be going through and fixing the fact that there are all these other files that could change that should force it to rebuild. What's a makefile? A makefile is what it sounds like. It's a file that has instructions on how to build stuff. It's a little bit complicated to get into right now, but basically the idea is that you put into it your source files and what output files that they generate. You build essentially like a... Let me reopen it. So you do things like you say, okay, I want to... In order to build, it's rules. In order to build this, I need to look for these files to see if any of them changed, and then I'm going to execute this command, and then I'm going to execute that command. And then I have these files here. You could do commands on them too, but I'm not. I'm just defining them as files that we want to look at for changes to determine if we should build this again. Realistically, I should probably be reworking this to be a little bit cleaner, more in terms of like the files that are... Well, I'm not building any of the files separately and then linking them together. It's all being included in just the main shooter.asm file, but that's another thing you could do. You could build a bunch of separate files and then bring them together. Sort of like when you were doing that. It's a little bit different because it's more of just like a smart command line tool to handle that. But if anybody is interested in that more, I'm happy to talk about it later. But let's I want to focus on this. So let me think about this here, because what I actually don't need to do the do I need to do the lookup twice? The problem we're going to run into is if I do this, then because we're adding BG tile, I guess we could just re-look this up. Oh no, but then why got clobbered? Boo. All right. Let's try and keep this simple. As simple as we can. So I'm grabbing this, I'm getting the bit, I'm doing the lookup, shifting it for the index that I want. I'm doing the clear carry, and then I'm adding whatever BG tile is to it to offset into the metatile. Transferring my Y to my A to Y so I can do my lookup into the metatiles, and then I'm storing that value into the new tiles. Now the thing so this is actually doing what I was saying, but it is doing it by storing. Okay, so maybe there's a way around it, but it's simpler to have it. So it's then reloading this offset, and then it's doing this. Which is just adding Why is this adding that again? That might be a copy-paste error. Let me go back for a second here. Load a temp clear. Transfer A to Y. Why is it... I don't know why it's doing it a second time there. That might be... because it's doing a branch, and then Y is getting clobbered there. So this might just be bad code. And then A is getting... yeah, so this doesn't need to happen here, technically. Although what I was going to say was it's kind of the right idea of what I was trying to do, which is that I want to do this alternating process here, right? So, and do two tiles at once instead of one tile at a time. So we get our bit, we do the index lookup, we add our BG tile, we transfer it to Y, we look up our thing stored in new tiles, and then we're gonna flip the bit on this, and do I want to store it first? I need to store it, right? And then what I need to do, well, yeah, that's there. So then what I want to do is I'm going to clear, and then I want to add temp to that. And then I want to transfer A to Y and load A with metatiles Y, and then store new tiles X. The only thing that we didn't do correctly here is we need to increment X. All right, and so then we're going to increment X again, and that should only be then the value 16 instead of 32. So, all right, so that gives us the loop through. I'm trying to think if there was anything I missed. And then this is where we're going to flip the bit. Just once we're done for the row, which is fine. Let's see. Now that we have this, load the loop strip. Oh, you know what we didn't do? So once we're done with once we're done with this, what we also need to do is we need to load A with loop strip, and then can I do, let's see, I don't remember. I know I can rotate right. There's arithmetic shift left, rotate right, shift right. Oh, logical shift right. That was what I was thinking of. Okay. And I can do that with A. I can also do it with something in the 0 page. Okay, so I don't actually need to load this. I just want to shift loop strip over, right? Because the idea is if, well, there's actually, we do need to do rotate. I'll get to that in a second. But if we have a value in binary like 101010110, right? Those are our bits. And what we're saying is that these represent the different metatiles that we want. And we're going to look at this one first, and then we want to look at the next one. We want to shift, right? Oh, stupid. I thought it just shifted once automatically. So when I shifted it right, obviously it got rid of that 0 and gave me now this information. So now we have a 1 here, and then I can do it again. And then we have a 0 here, and that's what we're going to keep doing until we're done loading the row with the values that we want. And the loop strip should only be regenerated after we have only after we have fully populated a full 16 by 16 metatile row. For now, what I'm going to do is just hard code the value just to make sure that that this part works, and we'll worry about the loop strip getting taken care of properly later. And there was something else that I didn't do properly. So loop strip is 2 bytes. Background loop metatile is only 1. I think we're only using it. Yeah, so I'm going to make this 2 because that's what we really want it to be. And then what that means is we have to obviously do 2 loads and stores. And then this gets to what I was saying about rotate versus shift. So when you do a shift, it will discard the bit. Oh, it looks like this one is actually not. It's shifting it into carry. Well, that's good. That's what I wanted. Is rotate? Carry is shifted. Oh, because in this one the carry is shifted in. Okay. That's actually not a bad thing. As long as we clear it when we do. So what we can do is we can clear carry and then rotate right loop strip and then rotate right loop strip. Or sorry, loop strip is our master copy. So BG loop metatile and BG loop metatile +1. So close the calculator. Yeah, so take a simple number like let's say, yeah, that's not a simple number. Let's say we have in our 2 bytes we have 1 0 0. Okay, so if you look in the binary, it's a 1 followed by 8 zeros. So these are the 2 bytes, right? There's the first byte, which is 8 bits here, and there's the second byte that's the second set of 8 bits here. And if we just shifted this and this without the rotate, what happens is while the bit gets shifted into the carry, it, I believe, does not then let's see, logical shift right. Yeah, so in logical shift right, if this one makes it to the end like it does in this in this byte, when we do our shift, it'll go into the carry, but then the problem is that we're not going to pick it up in the second byte. With rotate, what we want, actually we could do an LSR ROR. But anyway, what we want to do is with rotate, what it does is it takes the value from the carry and shifts it into the most significant bit. So if we shift this to the right, it's going to go into the carry, and this is going to become 0. And then we rotate this, the carry will come over to this bit, and then the rest of the bits will get shifted, which is what we want. It becomes a 16-bit shift right. And so we can actually I can do LSR because I don't care about shifting the carry onto BG loop metatile, but I do care about it. I do care about the carry on this BG loop metatile +1. We'll step through that so that you guys can see what I'm talking about here, because I don't think I did the best job explaining it, but it's actually pretty clear when you see it. So that ensures that we walk through the metatile list correctly. And then what I want to do is, after we clear our memory, I want to populate the, let's do a pattern that's pretty easily recognizable, just for the sake of testing, so that it's obvious that it's working or not. Too many bits. So that's our bit pattern, and we're going to store that into BG loop metatile and BG loop metatile +1. So that initializes those, and that's going to give us our bit pattern that we're going to then use for this process. So what I actually... let's see. Load Y BG loop metatile. And yeah, I think this is okay. And we're processing two tiles at the same time, so we're looping through this half as many times. Like I said, the only thing that I think we're leaving out in this process is we are not changing the value of the loop strip, which is fine for testing purposes right now. Just want to open the debugger and go to that code. Process game. Process game. So you basically use the two commands to simulate a shift right, but for 16. I mean, so it is a shift. It is a 16-bit shift. It is a shift right. Okay, but it's doing it for essentially for 16 bits. Let's do it here before we get into the game code, just so it's clear. And this way I can also confirm what I'm saying makes sense. So if we that's our 8 bits, we're going to store that into 0 and store that into 1. And then what we're going to do is we're going to LSR 0 and then rotate right 1. So what that means is that when we load A with the address 0, what we should get is the 1010 gets shifted to the right. So normally, oh, actually, let's do this so we have a bit here. So normally what would happen is, this would get shifted to the right, so you'd get 0101. But because we're doing the rotate, this 1 should end up in this nibble here. So we should get, except that I'm conflating two things. Hold on a second. Sorry. Because this is two separate bytes that we're dealing with. That's what I wanted to do. I wanted to make that 1 so that when we do it, we see that this remains 1, but this is now 1 because everything got shifted off. So when we load a 0, what we should get is we should get 11010110, I think. Let's see. That seems like that did not work. Let's take a look. If we just go up to the point where we do the logical shift right, we should have carry. Yeah, so carry is set. If we load A with 0 at the time. Oh, you know why? Because I am dumb. I am dumb sometimes. I wanted to load 1, not 0. There we go. So if we look at what D5 is in binary, you can see that what happened was we shifted 10101011 to the right, so this 1 got dropped, and a 0 would have gotten placed here, but because we're doing the rotate and the value was in the carry, it got dropped into this position, and so now we have 1101010101. So that was what I was trying to say. Just showed it the wrong way. So where is our code? Okay, so let's put a breakpoint here so we can kind of step through this code when it happens. And just accelerate the emulation because I don't care about this part of the game right now. Okay, so loop strip is why is the value 0 exactly? BE. What did I do? I'm sure I messed something up because I was talking at the same time. Load A with... Oh, yep. I sure did. Okay. Silly mistake. Reload the ROM. Run the game. At some point here, we're going to be able to actually, I'm going to try and get it so we can load the ROM onto my EverDrive with an NES hooked up through USB, so we can actually, through this USB HDMI capture that I have, and see if we can do stuff that way. So AA, that is correct. That is what I was expecting to see last time, because that's our bit pattern here. So we're going to load that and store that into BG loop metatile, and same thing. And so now you can see the 16-bit value is AAAA. So we're going to load BG tile and flip the bit using the exclusive OR and save that. We're going to clear out X. So let's load BG loop metatile. And then Y. Oh, we loaded that into Y. Oh, poop. So that's not going to work. I was not paying attention to the fact that we loaded that into Y. That was stupid of me. This is the thing, though, like, you know, talking and explaining and all that other stuff. So, not the first time, not the last time. Let's see. Yeah. All right. I think that's good. Let's reload again and we'll zip through. Come on. Okay. So there's our loop strip being loaded in. Load A with AA, and then we AND it, and we get 0, which is what we expect. So transfer that to Y. So then we do the lookup, and we get the value 3, and we shift it to get our offset. And then we store that into temp. We do our clear, and we add BG tile to get the actual tile that we want to put in there. Then we're going to transfer that to Y, and we're going to load the value and store that into new tiles X. What is the address of that? That is at 45. So we're going to see what did we store in there? We stored 62. Okay. And then we're going to load that and flip the bit again and store it. And so we have the value in there, so we're just going to clear and add temp to it. And then we're going to increment X and transfer A to Y to get our new Y value. We get the new metatile, and then we store that into new tiles X. So that's good. So that should have updated there. It did. Great. And then we have BG loop metatile is AAAA. So we're going to shift BG loop metatile to the right, and because we had A, I'm walking through this very deliberately so everybody kind of follows along. So the bit here, it was 0, so we did the shift. Carry is not set. Now the next time through, carry will be set. But when we do the rotate, right, so we have BG loop metatile, it's AA55. So now we're going to do the next shift, and we get 5555. So if we look here, it was AA, right? And now it is 55. Or actually, we can do the whole thing here, right? So that's what it was, and it became 5555. So now the next time through, this one bit has to carry over here in order for it to work properly. So that's the next thing that we should expect to see in the loop. So we're going to compare X, and it's not equal. Oh crap, that 16 should really be 32, because we still want it to be 32. Anyway, we'll fix that in a second. Let's just make sure that this is working the way that we wanted to. So BG loop metatile this time had a 1, I believe. So we now looked up the blank tile, and we're doing our transfers and stores. So 5D we got, that's fine. And then we're flipping the bit again, and we're storing that. We're doing our clear and our add, and then we're incrementing and storing again. 5D and 5E. So then we're going to shift right, and then we're going to rotate right. So from here, now the value that we have is AA2A. Really? So AA2A. Oh, it's because of the order we're doing it in. But yeah, so you can see that we lost the one bit that was here. This got shifted over. It's 2A, AA, is what we're looking at here. The order doesn't matter because we're being consistent about the way we're doing it for the purposes of that number. But you can see the bit that was here now got shifted over here in the rotate. So it got rotated out of the carry. You can see carry is actually set still, and doing that rotate added it to BG loop metatile. So we're going to increment X, and then we're going to compare it against 16, which is wrong. So let's go fix that. I was thinking, yeah, we're only gonna loop through 16 times, but it's still gonna count up to 32, which is not true if I half that value. So, all right, let's. All right, I won't walk through that quite as deliberately here as I was before. I really just want to make sure that BG loop metatile is B5. I just want to make sure that the bit rotation there continues to operate in a way that makes sense. I think it should. AAA. Yeah, so 1555 1555. Yep. So we're losing bits. The ones at the end here, at the most significant end, as they get shifted off. But that's exactly what we want. So let's see. The other thing I want to take a look at is the new tiles memory, which is at 45. So 62, 61, 5D, 5E. Okay. We should see it just doing that over and over again here. Yeah, that looks correct. So, all right, so let's do this. Where is the end of this branch, if not equal? So this is the end. So that will have populated the end of the, up until the end of the new row, or the new tiles row, and it didn't hit this part, the lookup, which is good. We don't want it to do that. And then BG tile, we need to flip it so that it is using the appropriate row. So I am good with, I think, just letting this kind of roll for a little bit and see what this actually looks like. So it's close. One thing that I did notice, which is fine, or I understand why it's happening. BG tile probably needs to be set to 1. Or just initialize the 0 here. Well, no, it needs to be 1 the first time we come in, because we want it to be 0 the first time through the loop. That's why this little wavelet is here on the left-hand side. It's because it's getting set to 1, and we're getting like the inverted pattern of it the first time through. So let's do that here. Load A, 1, store A. What was it? BG tile? BG tile. Let me just make sure. Yeah, we're not doing, I don't think we're doing anything else with it here. Okay, so that'll fix that. This is a little bit weird. I'm surprised we're getting these sort of doubled up. Something else is happening there that I'm not quite sure of at the moment. I don't think it's anything catastrophic, but it's just a little bit strange. So let's see if we can figure that out. Okay, so it was fine-ish. We actually want we want two things. We want, this should really be 3, because we want the 2 bits to be set for it so that it starts at the bottom row. And yeah, okay. But something else is going on, and it probably wasn't apparent when we were doing the full repeat mode with the same tiles, because it was the same tiles. So let's see if we can figure this out. Did I load A3, store it in BG tile? Okay. I reloaded the ROM, right? Just want to make sure that I'm not trying to debug a phantom problem from not rebuilding. I definitely have done that, so bear with me one more second here. All right, let's go back. Why? So the row is right now. We have the empty row, but this is now inverted in the beginning, which is weird because I thought the whole point of me setting BG tile to 1 or 3 was to fix that. So when we come into here, we're doing the exclusive OR. Which would set it to 0. And then we're looking up. We're looking up the tile, doing our shift, we're storing it. And then we're adding BG tile, which would be, in this case, it would be 2, which gives us our offset into the bottom row. But it shouldn't be giving us that wave. Well, okay, that's fine. So that bottom row might be fine, but then let's see. So we come into here, and then we do our exclusive OR to flip it from 0 to 1 for that bit. And then we store it, we do our add of the base index, and then we increment X and transfer A to Y, and we look up the metatile and we store it into new tiles. And then we do our shift and we increment X again, and we compare it to 20 hex, and then we come back. So then once we are done with the row, we should be coming in and seeing that this is set to, let's see, at the end of 32 tiles, it should be set to 3. Oh, and then we're not. Well, yeah, and then when we come back in here, we're flipping that bit to reset things. I guess we could do it at the end and then not have to. Wow. Let's see. Let's confirm that that's actually true. Just play through that section again. All right, so BG tile is, well, it's only 2. Why is it only 2? Why is it only 2? Let's go back to the beginning here, and let's make sure that it's coming in with the value of 3, like I thought it should be. Let's just do max speed on the emulation. Let me close the memory window just so that it helps it go a little bit faster. So, all right, so BG tile is set to 3, which is what I expected it to be. So then I do the XOR on it, and I get 2, which is what I want it to be. And then when we come out of it, the value is only 2. So what gives? It would be 2, 3, 2, 3, 2, 3, all the way to the end until it should be why did it come out with BG tile being only 2? If we're doing an even number of an even number of updates. Because when it comes into the loop, the value is 2, 0, and then we make it 2, 1. Should I validate that? That seems like it should be obvious, but it's something is not quite right. So coming in, do this here. Right, so BG tile is 2, which is what I expected it to be, so we're good here. It's still 2, transfer A to Y, do all that stuff, then load BG tile, do the exclusive OR. A is 3, so store BG tile that gets it to 3, clear carry, add temp, increment X, transfer A to Y, load store, shift, increment. So this is coming out 3. So now oh, but it shouldn't be, really. It should be 0. That's why. Because I'm doing it twice, but I'm not updating. Yeah. So then we don't need this to be this. What we really need to do is flip our bit again after we do our increment, or we can do it before, it's fine. And then we don't need to do it at the beginning, which means that we don't need to store the value as 3. We can store it as 2. So hopefully that took care of it. I think that'll do it. Yeah, okay. So we can go from 2 to 3, which is what I wanted, and then it should go from 3 to 2, which it did. And then it's just going to keep doing that until we get to here. Oh, except I accidentally, did I remove the breakpoint? I did, but that's okay. BG tile is now 2. Wait. Oh, populate single tile, it looped back to, okay. What I wanted to do was I wanted to break here. Now that we're done, and we're going to flip the bit, and we get BG tile is now 0, which is correct. And then when we come back into here, it'll be 0. And then we'll go from 0 to 1. Yep. Okay. That is what I wanted it to do. All right. Now, why is the second... So this one is okay, and then this one is wrong, and then this one is okay, and then this one is wrong. And then the second half is totally fine. Right? This is... Can I make this bigger? So this part, this half is totally perfect. Like that's one metatile, that's another. This, it's okay for the first one, but then the second one, it's not. And then for the third one, it's fine, but for the fourth one, it's not. And then the fifth one, it's fine. It's like it's every other one. Oh, actually, no, that's what I actually wanted. So why is it wrong here where it's always 0? Okay. Oh, because... Well, so that should be +1, although that shouldn't matter for... That wouldn't matter for... At least I don't think it would. That wouldn't matter for the problem we're seeing, because the 2 bytes are the same. So in this case, it would have been a problem later, but... why is this a problem? Load this, and then it does the and whatever. So... BG loop metatile shifts. Oh, because I am doing the rotate. Yeah, okay, right. So I reversed which byte is doing the rotate. This is my least significant byte, so this has to do the rotate. So that's... I was doing this backwards, and that was causing us to end up with the problem where it was using, because 0 is the wavelet metatile, it was using it was all 0 the entire time versus the alternating pattern that we have here. So what we should now see is... Man, it gets so slow as soon as you open up. Even at max emulation mode, we should see... Okay, so now it's actually just alternating between one tile on, one tile off. So if we change the pattern here and we say something like that, or that's maybe a little too regular. Let's do that. We'll still see it every row, but now it will be less repetitive looking. Oh, except I reversed. I forgot. I literally just said it, and then I screwed it up. It's a little counterintuitive that the pattern is that the 1 is the empty. That the 1 is the empty metatile, but it's easy enough to fix. Okay, so you can see now that that's matching the bit pattern we have, right? Where we have this is this. Wait, am I right? And then we have, yeah, so this is that, and then we have a bunch of empty space. Oh, no. Sorry, it's repeated, so we have 1, and then the empty space, and then another, and then because it's repeated, that's all we get. So now we can be a little bit more fancy and map data. Level data. Let me reverse this so that my brain is happy with the way that looks in the bits, and then 3, 4, 1, 2, 3, 4, and then we can do something like so I'm a little surprised. Did I do too many bits? No. Is the order... Maybe the order is skewed. Yeah, so it's doing it in reverse order. That makes sense. Okay. So I hadn't really thought about this because I was just kind of focused on the algorithm. And it's not really critical to what we're doing here, as long as we know it's happening. So what's happening is it is reading, it's starting with this bit, it's going in that order, right? So that's why this metatile that we're saying is 1 here, even though we're saying it's on the left, is coming in on the middle. And then same thing here. We're going, it's going, this is going bitwise, and this is going from left to right. We could fix that. I don't know how important that is for what we're doing here. Ultimately, what I wanted to try is the following. Let's do JSR this, and then store A into that. So we should be able to do this and get a random pattern in. And then what I want to do is every time we load a new row, that would be what we would do. And let's see how that looks. It may look like garbage, and then we will have a set of strips that we use. Okay, that's not like total solid chunks, but so now what we want to do is here, so branch if not equal to here. So basically what we're saying is if it's not 0, which means we didn't get to the end of the metatile and we're starting over again. Oh wait, is that true? No, at the end what we would end up with is 2, 0. So that's not exactly right. Let's or just 2, sorry. Bit number 2 set. So if the value is 2, then we're at a new row, and so we want to repopulate the loop strip. Oh, did I take that accidentally? I didn't mean to take that with me. Okay. Yeah, that was just an accidental copy paste. So let's see how that looks. That's a little concerning. I don't know why the palette color would have been adjusted by this, but okay. Okay, so yeah, so we're getting... That's not... It's a little bit like there's a little too much of it, maybe. Why? Why? Oh, you know why? I know why. Because we are... Are we messing up the Y register and we need it? don't know why that would matter here. Like once we're done with this loop. Branch if not equal. Let's just try this. I would be surprised that this is the problem. But oh no, wait. It's probably simpler than that. It might be because we're jumping. Let me comment this out. No, wait, we can't comment that out because we do need to skip it sometimes, right? If we command update tiles. Yeah, I don't actually think we need to do that anymore. Because we're updating the tiles. Skip, repeat, attribute update. Where was that? So I think this needs to be now in the same part of the code. Oops, go away, task manager. I didn't open you up. I don't even know. Really? Go, get out of here. Stop. Okay. What gives right now? Why am I getting phantom escape presses? That is really... Is it the drawing tablet that's doing this right now? I had the mouse resting on the buttons for the tablet accidentally. I'm wondering if that's what triggered that. Anyway, let's reload this. Still don't know why we're seeing that color change. Let me think about this for a second. Now that we've changed this process and we're coming out of here and the value would be 2. If we skip this, then we're not updating, we're not telling it to update the tiles. So if it's 0, when would it be 0 though? It wouldn't ever be 0. It really would be skip, repeat, attribute, update. When was it doing this? Update the attribute index, taking care to make sure that if we've gone off the top of the name table, we want to circle back. Skip, repeat, attribute mode. Load the screen mem and subtract 32. And then store it. And then branch if carry is set. So this is just a 16-bit subtraction from screen mem, and then we check to see if... So we're not doing anything with the attributes in here right now. Are we setting... We weren't setting the metatile flag anywhere in this commented code, right? No. Exclusive or that. Seemed like it was perfectly happy working this way, though. So, if we get to the point where we're at row 0, or BG mode 0, but it shouldn't... I guess it could go into there. And then we go into there if the next row we're updating is the top part. And then if it's the top part, we're going to skip over all this stuff to here, where we're going to change to the next row. But I don't know why I'm doing it that way. Because this should... I feel like that should be happening every time we do the row population stuff. And then that should be 2, because for the name table, it's straightforward. It's the attributes that are a pain. If I just get rid of that. There was a bunch of logic that was in there to deal with the attribute updates, but yeah, that seems fine even without that check. Which is what I thought, because it should be, I mean, we're drawing the row every time. So it's like, why are we going to this weird sort of trouble to check something and only conditionally do the update, which is bizarre. I still don't know what that glitch is about. We're going to have to figure that out at some point. So then, like I said, the only thing I would want to do now is if we populate a whole metatile row, which means that we've gone through from the bottom of the metatile to the top of the metatile. Now we're back to the bottom of the metatile, or to the bottom of the row. That means that BG tile should be 2. So we're going to compare it to 2, and we're going to branch if not equal to skip this part. And then if it is equal to 2, then we're going to update loop strip. Now, the only thing that we saw last time was that the call to that subroutine did mess up the Y register, but I don't know why that would matter. I also don't know why adding that code into here is causing the palette to be screwed up. Is it because of some sort of shared logic that's here now? I don't know. Let's see. So if we do transfer Y to A, push A, and then when we're done, we're going to pull A and transfer A to Y to preserve the value of Y. Does that stop that problem from happening? No. Why? That is bizarre. Why does it care? If we only call this once, let's see. No. And now it's fine. Why is that happening? Anybody want to hazard a guess? It's really bizarre. Let's see, if we go into the debugger and I go into here to set a breakpoint for when it gets called, I'm going to reset the game. I know for a fact that it gets called initially twice, right? And it never even gets called here. Is it something... I wonder if it's something where we're pushing some data over a boundary and it's not reading that data properly. It's the only thing I can think of, because it's the only logical explanation for why we might get this behavior. So are we doing... Yeah, so we're doing a load of a palette here. Let's take a look at this. So row mem... let's put a breakpoint. I have a feeling that row mem is like on some sort of weird boundary that's causing this. Again, it's the only thing I can think of that would explain why or how the palette would be affected by this. So forget about that for a second. So row mem is 9E07 and Y. Let's open the PPU. So we can actually watch it set the values. 1.07. Maybe it's the sprite palettes. Let's see. ROM is now at 9E17. Oh. That's interesting. So that is actually loading what palette number we want loaded and then just calling load palette. Oh, there it was. It wrote around. All right, let's take a look at load palette and see what's going on with that code. I mean, oh yeah, it's using palettes high and low. So yeah, that's the only thing I can think of is that we're but even then, that shouldn't matter. That shouldn't matter. All right, let's reload. So we're going to go in here and save off some stuff. We're going to load that, and that means we're loading the sprite palette. So param1 is 0. So we're going to transfer that to X, and then we're going to load palettes high, palettes low. So add param AF2A. Then we're going to add 4 to that and store that into param2. And then we're going to read out of 2002 and we're going to increment. We're going to compare that to 8. We're going to shift. So we're at 16. Store it and add 1 because we don't care about the background color. And then we're going to load 0 and we're going to add our offset. We're going to store that into 2006 and that's what we're going to write to. And address parameter 1 is going to be that with the value of y. We're just going to do that until, okay, so I don't see anything particularly wrong with that, but we know that the last time around it is a problem. So let's see why. Load palette. Oops, why is it doing that? Why is it doing that there at the same time as I am load palette? Yeah. So let's go back to here. Okay, so we're on the last one now. So we're saying load palette 3. And that's param1. And then we're going to OR it with the bit there to tell it it's a sprite palette. And then we're going to store that into param2. It's sprite palette 3. And then parameter 3, we're going to load that. And I think that's just our counter, maybe, or something. I don't remember what we're using that for. But okay, so then we're going to go into this. We're going to store off all that crap. And we're going to load this, and we're going to end it to see if we're doing a sprite palette. So we are. So load param1, which tells us that we are doing the final sprite palette. Or no, sorry, we want, well, it amounts to the same thing. We want the third palette. So let's see, what do we actually get here? 2A0E, and then we're going to load param2 and clear and add, and that gives us that. We do our shifting, and we increment so we get past the background color. Load a 3F and store that, and then we load a with a 0, and we add our offset and store that to 2006, and then we're going to load Y with 1, and then adder param1 is 2A0E with a Y of 1, so we get our value. We store that into 2007. But that is already, shouldn't that be storing here? Is our calculation off? And I don't remember what the, actually 2A0E. That seems goofy also. That seems like that's not right. I mean, that's why we're updating the palette over here, because we're overflowing the bound. And then we're done. And we've messed up our background color. Why? Okay, so there's two problems that don't make sense. Why did that break? You know what? It was probably always broken. It's just something got shifted so that we're reading garbage data for the palette and causing this to happen. So let's go in and see what adder param1 actually looks like when we know it's basically right. AF2A. Yeah, that makes more sense, because that's an actual, like, AF2A is like a ROM location that, yeah, that seems correct. So why is this so screwed up? If we come into this, we are looping through load a Y. Are we not using Y? We are using Y other places. Oh, but we're not doing anything here. Load Y0. Store A. I wonder if it's because we're not... When we come in, are we messing with Y at all here? We are over here, but do we always go over there? Map slow. Like, I'm just trying to understand why this would be... It doesn't matter. I mean, like, y is 0 here, so let's... We're setting up the palette correctly in this case. Okay. So we increment it, we compare it, and it's not equal. So when we come out of that subroutine, it should be 1. So add a param 1 AF2E. Still makes sense. That still seems right. Okay, that looks fine. We increment, that's compare y4. It's not equal. So we get the value 2. And then we're going to store that into param 1. And then we're going to transfer y to a. And then why are we doing... Oh, because it's, right, it's sprite index 2, param 3, we're going to load now. And it is... Yeah, so we are actually going to set the palette. So when we come out, y is set to 2. We compare it. And this is our last time through, so we get 3. We store that. We transfer y to a. We do our 83. We store that. We load param 3. And we go into here. So is it just that adder param is wrong? So x is 3, that we want the third palette. Do we have a third palette? Is that... There is project palette. It's high. 0, 1, 2. Okay, so we don't actually have anything here. So that doesn't help things. We can reuse, we can just force it to reuse that palette. It's weird that again, I'm still not sure why the random number calls triggered that. Maybe it just shifted some code in a way that, because we were indexing into a palette that didn't actually exist, it was not a problem before. Or not code that didn't exist, data that didn't exist. Okay, yeah, so that fixed it. That's weird. That's really weird. Huh. Very, very strange. speed this up. I want to see what this looks like and kind of where we're at with this now. All right, that's not terrible. It's a little bit too dense. Although still not the worst I've seen. Let me go to the performance profile. How expensive is that random number generation? It's not too bad. So, all right, so that's cool. So that actually worked. So like right now, we're not calling the random number generator at all. And then we start calling it now. Every row that we are updating. And the nice thing about this, like I talked about last time, because it's using a seed, the random numbers, the randomness is not actually truly random. It's repeatable. I don't know. I don't hate this. It's a little bit. I feel like maybe I want to invert the bits. Like, where is... If I just do an exclusive OR to invert the bits, is that better? Because I want it to be a little bit sparser. And maybe that's not going to be possible. But it seems like it's a little bit... Yeah, so that didn't really... It really didn't change that much. I guess it's a little bit better. But it's not a total loss, right? Like, so one of the things that we did was we set up a system and 2 consecutive. Yeah, that's not a bad idea. Let's try that. Are you thinking like call it twice and the result? Like do this and then can I do this? I think I can. So call it twice, anding the results together and then storing it back in. Let's see. Oops, what did I do? I forgot to grab that. XOR if it's the other bit. Let's see how this looks. I'm curious to see. This would definitely lend itself to being sparser. Just because then it's not just whatever the bits are, it's how many times the generator will generate values that have bits that overlap. Well, it's definitely more sparse than it was. But that's looking pretty good. No, I don't think that's too sparse. I actually like that. Oh, the first section, yeah, where I was manually populating it. I mean, that's the thing with the way I populated it manually. It's actually way more sparse here, right? So I either have to step up I have to add more little wavelets to it, or I have to make this even more sparse. Even though, like, it's not bad, I think but because they're static, it's like it might just be too much. You know what we could do? Let's try this. We'll AND it against the previous result. Let's see if that... So whatever the previous value was that was in there, we'll AND it against the new value and then... see if that has any appreciable difference. Now it all disappeared. Initially it had a value and then that's interesting. I wonder if that's just a function of the way that it generates the random numbers. Like you can clearly see it starts off with some bits and then it like decays into nothing. Yeah, it's ANDing and storing. Let's try exclusive ORing it. We should definitely end up with more bits turned on. I wasn't expecting it to totally decay into nothing. Now we're back to it being a little bit too... or not a little bit, definitely too much stuff. Let's try this. Cross AND. Yeah, I thought I don't know. It looks okay. I'm kind of on the fence of what I like better. I like this is a little bit more sparse with the wavelets, but when we started doing what we were doing to thin it out a little bit, it definitely looked good. It looked better than just having the fully repeated pattern, obviously. So AND is a definite no, because AND just seems to cause it to decay into, or the way that I'm doing the AND with it feeding back on itself is definitely a no. Let's see. See, and the thing is, like, because this is just purely being done randomly, I may never come up with a way of efficiently distributing these values to get something that looks good. I mean, again, it doesn't look terrible. I'm actually kind of okay with the way that looks to some extent, but it's just a lot, especially compared to the map areas. I think it's definitely visually interesting because there's kind of no clear pattern to it. But I also like this being a little bit more clean in terms of the fewer little wavelets. So that kind of brings us to then, do we make use of this to have some preset strips that we use, and then we just kind of mix and match them randomly? Kind of along the lines of what you were saying, Miralupa, last time, where you could have them saved off and just have like 4 or 5 of them that we stitch together as we go. Because that would definitely allow us to be a little bit more sparse. And then the randomness is just kind of how they get put together, rather than how many, like, this is very random. I think that's probably what we should do, is just come up with a few that are pre-made and stitch them together. And if you're watching going, I told you so, that's fine. I wanted to see it, like, to know that I either didn't want it or whatever. Because I feel like it needs to be kind of half as dense as this. And I'm not sure how we could do that with essentially generating 2 random 8-bit numbers and like some sort of bitwise. Well, you know what? I take that back. We could do something like, oh, except I want binary. Right, I could do an exclusive OR like this, where we're deliberately eliminating all, or we're deliberately trying to eliminate some of the middle wavelets. Kind of like, I guess, as a filter. But I don't know what that's going to look like. Like, that's just a pure speculative attempt here. So let's see. This could be completely worse than... Well, it doesn't look worse. I mean, the thing is, if we do something like and do something like this, then obviously there are going to be spots where there just will never be wavelets. And then it's really down to like the randomness of the number to determine if the bits that we allow actually will end up having values. But the thing is, that doesn't allow for the the natural layout where we have, sort of very, some packed tightly, some sparsely. Like, we're just using noise, right? Like, there's nothing like in other areas where you would use some sort of randomness to create something, like distribute things randomly on the ground or whatever. You wouldn't just do it completely randomly. You'd use other types of things like blue noise instead of white noise, or other kinds of noise patterns, and that would help you get something that looks a little bit more natural. You can spend countless hours coming up with something that works, but you could make something really nice rather than quick external. Yeah, no, I agree. And that's kind of the thing, right? Like, we could sit and mess around with this. I agree, for a long time and get something that we're like kind of happy with, but not 100% happy with. So, yeah, you're right. I just wanted to try this and see, like, what does that actually look like? Can we get anything decent out of it? And the answer is we can't. Or not easily anyway. And the other thing is also to do the kinds of calculations you need for the kind of randomness that you would need to make it look interesting or correct is like beyond what the NES can do. So just want to make sure that this is still working. Yeah. Okay. So in the next stream, I really want to understand what's going on with that little hiccup that we're seeing there. It seems like it's a shift in the scrolling, which is different than what it was before. It looks like what's happening is we're hitting the end and the scrolling is jumping and then coming back. And that might be as a result of some of the coding that we had done for the repeat scroll mode. And it looks like it's happening as we're loading up, some of the tiles, and we're getting some junk in there as a result. Like, it's not junk from the map. It's like junk from scrolling in while we're in the process of updating the name table, which is why it's so like weird looking. So we'll have to see what's going on with that. That's the best that I can figure right now, is that we're actually jumping too far and then coming back. That's what it looks like. Even though we don't see that here in the PPU viewer, the emulation seems to be showing that. And it is happening on real hardware too. So it's not the emulator doing something bizarre. It is a bug. Oh, wait. So it's actually, that's interesting. So it's actually jumping to the top name table and then back down. All right. I got to remember that for next time. I don't want to go any longer because it's already been over 2 hours. And I know that I spent some of the time talking about the video from Casey, but I think it was worth going over again. If you haven't watched it, but you're at all interested in the idea of good code versus bad code, definitely take a look at it. So As always, thank you for watching. If you want to reach me on Twitter, I am at Clairvis. If you want to reach me on Discord through Video Game Sage, I am Zelius. I am Clairvis on Discord as my main username. I don't know why I decided to do two different things. Good night, Microman. Thanks for joining. Appreciate you stopping by. And yeah, feel free to ask questions or comment on the video uploaded to YouTube. Email me if you'd like to, zelius@gmail.com. See you later, Miralupa. Thanks for stopping by. And there's a Patreon and a Buy Me a Coffee and all that jazz. Drozerix, take care. And I will see you Thursday at 9 Eastern. Have a good evening, and thank you again. See you later.